We are we are back, and we are still trying to learn web frameworks. Um, but I am pretty excited by this because Actix 4 is out, and I looked at it like months ago, and it was just like, this is too complicated. I'm not going to be able to understand this. And on top of that, I saw that they were about to release 4 because they were still on 3, so there were going to be breaking changes. And I was like, I'm just going to come back to this. Now we're back. So I'm going to be learning. I'm going to just be going through the basics. This thing. I tried to find like a blog or something or a tutorial or something like that, but it just came out. There's not really anything in version 4, and I wanted to keep it consistent. So yeah, let's see. Actually, let me grab the chat real quick. There we go. Yeah. Okay. Cool. Now I can see your messages at the same time. Yes. All right. So installing Rust, we're just going to assume Rust is installed. Cargo new, and then we add Actix-Web 4. Cool. So let's just do that. Not this. Not this either. Okay. Let's go to our TOML. Actix-Web. Not 0.4, 4.0. Well, I guess there's probably a newer version. It's probably this. Let's see. Yeah, nice. Okay. Request handlers use async functions that accept 0 or more parameters. What are they talking about? Are we just jumping in? Yeah, I guess we're just jumping in. These parameters can be extracted from a request. See from request trait and returns a type that can be converted into an HTTP response. See responder trait. Okay. So you have your like paths, which you decorate on your async functions. So I'm guessing there's some sort of runtime, Tokyo or something. Oh, thanks, Kathleen, for the audio check. I appreciate that. I've definitely just mouthed to the camera before. So we're going to get these imports. It doesn't have a main here yet, but it looks like we're just passing these functions into HTTP response OK body. These are just inputs, so let's see how it feeds those in. And we're returning a implementation here, an implementation type. So this could be any actual type that implements responder. So we'll see. So notice that some of these handlers have routing information attached directly here, right? I think that's what they're saying. Using the built-in macros, these allow you to specify the method and path that the handler should respond to. Okay, so it's saying this is the method, I guess, and then this is the path. So we're saying get, home, post, echo. Gotcha. You'll see below how to register manual hello, which is not done this way. Routes that do not use a routing macro, right? So next, create an app instance and register the request handlers. Use app service for the handlers using the routing macros and app route. For manual routed handlers, declaring the path and method. Finally, the app is started inside an HTTP server, which will serve incoming requests using your app as an application factory. Okay, so I'm going to go through this just to get it in my fingers because this seems like a pretty common pattern. So let's see. We don't have any of our imports here yet, but we're going to do Actix-Web main. Okay, so it's not Tokyo, it's Actix's web or runtime async function. I'm trying out Copilot. If you have opinions about Copilot, let me know. I just turned it on. It's kind of weird. So this is returning to standard I/O. I wonder how that would change when we do things for real, not just in our terminal. So it looks like we're building an HTTP server, which is nice. And then it's a closure. It takes a closure of an app. And in that app, we feed services. So I guess services are like functions. They're like things that read functions. And we're gonna paste these other functions in here from before in just a second. Okay, so then we can add one manually. I guess this is what they were talking about when they were showing the one that did not have the decorators to, yeah, so manual, hello? Oh, L0? Okay, right, so you do webget instead of the decorator, webget.to. Okay, yeah, and then we need to bind this HTTP server as a tuple of the base port. Oh, and then that's a pretty common thing, I guess. Makes sense. Then we run the server and we await because it is async. That makes sense. However, we need to also bring in all of our imports and these functions that we sort of skipped over. So, any red text? No, looks good. So this we should be able to do things with, right? Are we already up and running? That'd be cool. Let's see if this works. The first compile is always the longest. But we're just going to curl this. Okay, so it's running. Nice. We're just going to curl. Oh, what is that? I don't know why it's not letting me autocomplete. We're just going to curl this local port. Nice. Okay, so what just happened? It ran, and it printed hello world. Classic. So it hit this because we did this path, which sort of makes sense. So what does echo do? I guess I would have to understand what post does. So this is like getting it and returning it to standard IO. So if I did hey, it would do the same thing, except they're showing us the difference between the decorator and not the decorator. So if we did this, yeah. All right, it's working how I thought. Let's see what this does. That did nothing. I guess I don't know what posts do. But it didn't like error, right? Okay, no, that does the same thing. I don't know what I'm doing. Let's keep going. Can't stop moving. That's it. Okay, compile and run the program. We did that. Actix-Web main macro executes the async main function within the Actix runtime. Cool. Bunch of magic stuff happening that I don't understand. Now you can go to this. We just curled it, or any of the other routes you define to see your results. Cool. Yeah. So we could technically, I guess, do this in a browser. right? And do OK. No. Oh, it has to be running. Duh. We run this again. It's running immediately. We try this again. Nice. Yeah, curling is faster, I guess. But once we start doing things in an actual browser, that'll make sense. All right, and that was getting started. So, application. So, writing an application. Actix-Web provides various primitives to build web servers and applications with Rust. It provides routing, middleware, preprocessing of requests, post-processing of requests, etc. All Actix-Web servers are built around the app instance. It is used for registering routes for resources and middleware. It also stores application state shared across all the handlers within the same scope. Okay, that's going to be cool if it's like a consistent API and I can just remember the complexities because they're always the same. An application scope acts as a namespace for all routes, i.e. all routes for a specific application scope that have the same URL path prefix. The application prefix always contains a leading /. If a supplied prefix does not contain leading / this is what they call it, it is automatically inserted. Okay, so you can't mess that up. The prefix should consist of value path segments. All right. For an application with scope app, any request with paths /app, app / or /app /test would match. However, the path application would not. What is it saying? This is just an example. So this is just text. And then we have our app in our server. This is all the same. Okay, so we have a scope here. So this is going to have everything beneath it, I guess. And then we have to scroll. And then we have a route. So routes and services are different, I guess. So whenever you go to here, it's going to get this, which you have to call this way because it wasn't decorated. So they're just showing us this part, I guess. Although you could technically put it here. I don't know. I think so. In this example, an application with the /app prefix and an index.html resource is created. This resource is available through the /app index.html URL. So we can check out URL dispatch. Okay, it's pretty straightforward so far. Make sure my thing's working. Cool. State. Application state is shared with all routes and resources within the same scope. That's why it's a closure, I guess. State can be accessed with the web data T extractor, where T is the type of state. Oh, so this means you can make your own structs. That's cool. State is also accessible for middleware. Let's write a simple application and store the application name in the state. Let's see. Do we run this in main? Yeah. Okay. I want to type this up because same reasons. Here it. And then let me find stuff. Okay. So we're going to, oh, I was, whoops. Okay. I was not in insert mode. Okay, so we're going to need get web app and HTTP response. So I think those are pretty much the basics of what you would need, right? Good Copilot reminding me about that. Semicolon. Okay, so we can make a struct, just a generic struct about app state, the app name, It takes a string. It holds a string, I guess. And then we can incorporate this into one of our functions using web data. So that's cool. It this path async function index, call it data, and then in the web import have data, and then we can just give this whatever type we want, right? So we can use our own custom structs. That's really cool. I guess if we're going to extract it, we have to know what's inside of the struct. So it would be a string, which would change. So that's interesting. And then we need to set a variable. And this would be a reference to the data we fed as a parameter and its app name. And then we format with hello, person, name. Oh, actually, Rust is new and shiny, so we can do stuff like this. Cool. Cool. We can just put it in line. That's great. So this is not going to run because we don't have main. So we have to build the main. Actix. Okay, yeah. Autocomplete with Colab is kind of weird. There we go. Actix-Web main. Does save you time whenever it works, though. Function main. And then this still returns to standard out, so we can see it, I guess. Although it did print in the browser when we saw it, so that's interesting. And then we build the server again. Still takes a closure. Open app. New. And then that app is going to take app data, which is not from our function. That's just a method on the app struct, I guess. And then let's see, we have to call data new. So we're like instantiating, I guess. Interesting. Okay, and then we can initialize. So app name string from Actix. Right, so that's the example. And then once we've initialized, okay, so we're like feeding data with app data into our app. That's cool. Okay, and then we add the service, and then we do the that bind to whatever. Not this. 0.0.1. Complete. Nice. 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 Okay. Do we not import this? Oh, it's not response. It's server. Wait. Do we need response? I don't think so. Anything wrong with this? No. All right, let's try it. Oh, it's still running. Whoops. Building, running, home. Nice. Hello, Actix-Web. Okay, so that took information from our struct that we instantiated and then fed into it. That's cool. I like that. Okay. Any number of state types could be registered within the application. So you can use a bunch. Cool. shared mutable state. HTTP server accepts an application factory rather than an application instance. Thus the closure, I guess. An HTTP server constructs an application instance for each thread. Therefore, application data must be constructed multiple times. That's why it's async, I guess. If you want to share data between different threads, a shareable object should be used. Example, send plus sync. Okay. Makes sense? Internally, web data uses arc. Thus, in order to avoid creating two arcs, we should create our data before registering it using app data. So not like what we did. In the following example, we will write an application with mutable shared state. First, we define our state and create our handler. This also has a main. Cool. So let's look at this one. How much of this can I salvage? Oh well. Let's see. So here, Actix-Web, and then we're only going to need web app HTTP server, which I got wrong last time. Server. Okay. But we're also going to need sync and mutex. Cool. We're going to use mutexes. So we're going to make a app state counter this time to show the multiple threads, I guess. It's going to be mutex of I32. Then it needs async function index data is going to be web data, and then we can feed this. So this is cool. This is a cool API. We can feed this state with counter into our data, our web data, and it's still going to return. Is it going to return a string still? I guess. How is? I guess it's a string when it comes out of web data. I don't know. That sounds wrong. So this looks right. Counter equal data dot counter dot lock for the mutex. Unwrap to get the value. That will get the number out of the mutex, and then we look at the number and we increment. Right. And then we need to print it so we can see it. Request number. Sure. Cool. That is our function. We need the main again. Let's see. Actix. Why does it? That doesn't exist. Why does it say Actix runtime? The Actix-Web main. Okay. Another async function main that returns standard IO result around. Okay, so this is what they were saying, is that we have to create the data outside of our HTTP server here. So instead of instantiating inside the app, we're going to do it outside the app, at least initially. Save the counter, mutex, new, starts at 0. Yes. Oh. Why is it not? Okay. Okay. And then after that, we can make our server. Here we have to do a move into the closure so that it's not owned, I guess. And then, which means we're gonna have to do a clone, right? Oh, caps locked. New. And then we feed app data again. Cool. And we add the root. And it was not decorated, so we have to do webget to the function. Then we have to do the classic. I don't think this should exist. Okay, yeah. Do the bind. Good. Bind this thing again. 0.1 finishes it. Finishes it. Finishes it. Nice. Okay. So what is wrong? Anything wrong? No. Cool. So if we run this at the root, we should get an incrementing counter. Is it still running? Try again. This is fun so far. I thought it was going to be, I mean, I'm sure this is the basics, but it's been fun. Okay, so then we should get, so we got one, we should get two. Nice. It's doing it across all the threads, huh? I think I have, will this see how many threads I have? No, that's not how that works at all. Okay. Nice. So we just did this. And we did it with our own struct with a mutex. Cool. Using an application scope to compose applications. The web scope method allows setting a resource group prefix. Yeah, that's sort of what we saw before. That's cool. This scope represents a resource prefix that would be prepended to all resource platform or resource patterns added by the resource configuration. This can be used to help mount a set of roots at a different location than the original author intended while still maintaining the same resource names. So it makes it more modular. I like that. So here they're just showing an example. Show users. So you can have scope, and then you can attach this. You can build this function in a way that it attaches to different scopes because we have this scope function. That's cool. And then we just pass it in like this. So we're building the scope separately and then passing it in as a service. That's an interesting pattern. In the above example, the show users root will have an effective root pattern of users show instead of show because the application scope argument will be prepended to the pattern. The root will then only match if the URL is users show. And then the HTTP request URL for function is called with the root name show users. It will generate a URL with the same path. Makes sense. Guards and virtual hosting. Application guards and virtual hosting. I don't know what those are. So let's see. You can think of a guard as a simple function that accepts a request object. So it's sort of like an assert. Yeah, references a request object reference and returns true or false. Sounds like an assert. Formally, a guard is any object that implements the guard trait. Actix-Web provides several guards. You can check the function section of the API docs. One of the provided guards is header. It can be used as a filter based on request header information. Interesting. So let's see. See if I can fit this on a screen. So we're doing all the normal stuff of making an app, calling a service with the base scope. Okay, and then we have this guard here. So instead of declaring a scope as a condition, we're setting a guard with guard header. And the header is looking at the host, and it should be wrestling.org. So it will true or false based on that, and then return or not return based on the true or false. Interesting. Does this take a guard? And then I guess this is the thing that returns the true or false, and then guard just checks the true or false. Interesting. And then it adds a root of nothing. And then we're just inline building this async function, I guess. I'm calling web2. And then we do something here that does the same thing except for users wrestling. So we're basically excluding everything but www and users. Cool. And then it will call everything else. I think that's what that's doing. So that's good to know. Configure. For simplicity and reusability, both app and web scope provide the configure method. This function is useful for moving parts of the configuration to a different model or even library. Yeah, so that sounds super important. For example, some of the resources configuration would be moved to a different module, could be moved to a different module. Okay, so all the regular stuff, this function could be located in a different module. Why is that? Oh, it's not saying we can move it there, it's saying it could just be there. And it's just a config. So we're sort of imposing this config when we call this function. Okay. And this could also be located in a different module. How are these different? This is a scoped config, but there's no scope called. Let me see if I can get a better look at this. Really small, I guess not. I wish this window would open up wider, but oh well. And then, so this is test. And I guess they're just saying both of these could be somewhere else. Okay, but he's calling configure on config to set up the service. Method not allowed. Root method not allowed. Okay, body app. Okay, body test. So we can basically take this function from somewhere else, which it's not async, so it needs to be inside of an async, which it is here in main. So we feed the config to the configuration method of the app, and then service is scope API, configure scoped config, root base. This is a little over my head. So let's see what it says. This will return this. This will return app, and this will return test. So it's saying, okay. So it's saying that this configure can take a scope. So it'll be API test. But we didn't have to include the API part. We just put it here. So we could put this test in multiple places. I think that's what it's saying. But we can also just, so we can just stack these things together. That's cool. Each service config can have its own data, routes, and services. Right. Servers next. Sometimes I forget there's a dog down here. HTTP server. The HTTP server type is responsible for serving HTTP requests. Okay. HTTP server accepts an application factory as a parameter, and the application factory must have send plus sync boundaries. More about that in the multi-threading section, which we will not get to today. Maybe. We'll see if that's in the basics. To bind a specific socket address, bind must be used, and it may be called multiple times. To bind SSL socket, bind rustls, socket something, socket location, rust socket location, or bind OpenSSL should be used. To run the HTTP server, use the HTTP server run method. Okay. Okay, so this is like a return. AS2 wants a return, and then it just runs that function or return type. So this is like bare bones Actix, I guess. It just returns an OK, which makes sense. So they're just showing us the server. The run method returns an instance of the server type. A server must be awaited or spawned to start processing requests. It will complete when it receives a shutdown signal. Actix-Web listens for system process signals by default. Okay. The following example shows how to start the HTTP server in a Tokyo task with multiple commands and shut down using a server handle. Ooh, so we get to use Tokyo now? Interesting. Okay, yeah, so we will get to multi-threaded. Let's see what this does, though. We get to use Tokyo instead of Actix, which is interesting. Let's try it. We're going to need to import, I guess. I could just type it, but I want to see what it does. Okay. Nice. So 1.17. And then I guess we have to write this. Okay. So we're going to have all of this same stuff. We're also going to have HTTP response. We no longer need mutex. We are going to need standard IO. And then the rest of this we don't need. So this is the part that's different, is we're going to use Tokyo main for some reason. We're going to use that runtime. And then the main IO results. Let SRV, what is it? What does SRV stand for? Equals HTTP server new app new root of base web bit 2, and then I think this is just a response. Yeah, HTTP response OK, which makes sense. Response OK. Sounds right. Let's see. I don't think I need this semicolon though. Yeah. So then we're just going to get rid of that. And then still binding. Binding to same thing as always. Yep. And then, okay, so we're going to do one thing different, which is have a shutdown timeout. Interesting, for 60 seconds. Let's just do 30, because I want to wait a whole minute. Run, okay. So I guess what it's saying that's different here is we can pass different things. We can spawn different threads. So we can obtain a handle to the server. SRV. Looks like the server is just running now. Oh, no. So we're not awaiting the server. But we can call it because it's a variable. Okay, so we can get the handle from it as a variable. And then we can spawn with Tokyo. Start processing. Separate of the handle that we just grabbed. And then we can pause, accepting new connections. Interesting. Pause, wait. SRV, handle. And then we can resume. And these are all going to be async because this is all called from the handle function, which is on a different thread, I think. Handle stop. True. Wait. So that's going to shut it down gracefully. And then we return OK from main. Failed to resolve, could not find main in Tokyo. What? Did this whole example not work? Did I? It's like not how you import Tokyo. This is not going to work, right? Right. Well, crap. I guess we're just going to have to take them on their word for that one. Live television, folks. Yeah, I don't know what's going on there. If you know what's going on there, let me know. Either live or in the comments. Multi-threading. HTTP server automatically starts a number of HTTP workers. By default, this number is equal to the number of logical CPUs in the system. This number can be overridden with the HTTP server workers method. So we build a server, feed an app factory, set the base route, return OK, and okay, so you can tell it the number of workers, basically is what they're saying. And that ties on to an app. It starts 4 workers. Once the workers are created, they each receive a separate allocation or application instance to handle requests. Interesting. So it's like it feeds a worker to the app, and it feeds a worker to the app, and they all run separately on the Actix runtime. Handlers are free to manipulate their copy of the state with no concurrency concerns. Yes. Application state does not need to be sender sync, but application factories must be send and sync. To share state between worker threads, use an arc. Special care should be taken once sharing and synchronization are introduced. In many cases, performance costs are inadvertently introduced as a result of locking the shared state for modifications. Yeah, that would be trouble. It'd be hard to diagnose too. In some cases, these costs can be alleviated using more efficient locking strategies. For example, using read-write locks instead of mutexes to achieve non-exclusive locking. but the most performant implementations often tend to be ones in which no locking occurs at all. Right. Since each worker thread processes its request sequentially, handlers which block the current thread will cause the current worker to stop processing new requests. So this is what you're not supposed to do. Will cause the current worker thread to hang. Yeah, so if we pass it a function that has some big delay in it, it will block the other ones. It's waiting. Not awaiting, but waiting. For this reason, any long non-CPU bound operation, like I/O, database operations, etc., should be expressed as futures or asynchronous functions. Async handlers get executed concurrently by worker threads and thus don't block execution. So delay for duration 5, await. Okay. Yeah, so it will pass this until we'll move on because it's awaited. Although I don't know how to get Tokyo to work apparently. The same limitations apply to extractors as well. When a handler function receives an argument which implements from request, and that implementation blocks the current thread, the worker thread will block when running the handler. Special attention must be given when implementing extractors for this very reason, and they should also be implemented asynchronously where needed. Okay. TLS and HTTPS. There are two features for the SSL server, RustLS and OpenSSL. The RustLS feature is for RustLS integration and OpenSSL is for OpenSSL. Makes sense? I don't know what these things really are. So I'll probably look that up later. We're using version 4, and then you have to add the feature of OpenSSL, as well as import OpenSSL, of course. And then we have an SSL acceptor, SSL file type, and SSL method. Interesting. So you have a simple function that just returns a string. And then, so we're going to load SSL keys. Yeah, so this is some like security stuff I'm not going to understand. Creates a self-signed temporary cert for testing. This is like a command line something, which is pretty gibberish to me. Looks like we're going to make some keys. So let mutable builder, SSL acceptor, Mozilla intermediate, SSL method, TLS unwrap. Yeah, this is all going over my head very quickly. Builder, set private key file, key, PEM, I don't know what that stands for. File type PEM, unwrap. Set certificate, chain file, cert PEM, unwrap. Oh. And then we do the regular stuff. Passing this function into our service. But our bind is not just regular bind anymore. It's bind with OpenSSL. So I guess this is just how you add security onto things, onto your server, which is, you know, obviously basically a requirement. So I'm going to figure that out. To create the key PIM, insert PIM, use the command, fill in your own subject. We're not going to do that. That is for later. To remove the password, then copy no pass PIM to key PIM. OpenSSL RSA in key PIM out no pass. I don't know what any of that means. Okay. Keep alive. Actix-Web keeps connections open to wait for subsequent requests. Keep alive connection behavior is defined by server settings. Duration from second 75 or keep alive timeout 75 enables a 75-second keep alive timer. Keep alive OS uses the OS keep alive. None or disabled disables keep alive. Interesting. So Actix-Web, HTTP, keep alive in server, time, standard time duration, and then we have some anonymous functions here. So we're making multiple servers to be kept live at different times. It's saying that OS is usually quite long. Interesting. If the first option above is selected, then keep alive is enabled for HTTP 1.1 requests if the request does not explicitly disallow it by, for example, setting the connection type to close or upgrade. Force closing a connection can be done with force close method on HTTP response builder. Keep alive is off for HTTP 1.0 and is on for 1.1 and 2.0. That's probably something that normal people will know because they understand how web stuff works. What do you want? You want to go outside? Go. Let me let this dog out real quick. She's going to get out there and realize her mom's not home and be mad. Okay. Graceful shutdown. HTTP server supports graceful shutdown. After receiving a stop signal, workers have a specific amount of time to finish serving requests. Any workers still alive after the timeout are force dropped. By default, the shutdown timeout is set to 60 seconds, or 30 seconds. You can change this parameter with the shutdown timeout method. HTTP server shutdown timeout. HTTP server handles several OS signals. Control-C is available on all OSs. Other signals are available on Unix systems. SIG-int, force shutdown workers, SIG-term, graceful shutdown workers, SIG-quit, force shutdown workers. It's possible to disable signal handling with HTTP server disable signals method. Oh. Okay, we're officially in the realm of things I don't understand. That's good. We're learning. We're learning things. Let's keep going with request handlers. A request handler is an async function that accepts 0 or more parameters that can be extracted from a request, i.e. implement from request, and returns a type that can be converted into an HTTP response, i.e. implements responder. Yeah, so that's sort of like what we were doing before. That's good to know. Request handling happens in 2 stages. First, the handler object is called, returning any object that implements the responder trait. Then, respond2 is called on the returned object, converting itself to an HTTP response or error. By default, Actix-Web provides responder implementations for some standard types, such as reference to tick static stir and string, etc. For a complete list of implementations, check responder documentation. Examples of valid handlers. Async function index request HTTP request reference to tick static stir hello. Okay, so this is a valid handler. This is also valid handler. It's just toOwned, so it returns a non-reference to tick static stir. It's just a string. You can also change the signature to return implementation responder, which works well if more complicated types are involved. Yeah, which is what we were doing before. So here we could return box feature item HTTP response error. So I guess that's what responder is. I think that's what they're trying to show us. That the implementations of yeah. So responder defaults to calling respond2. So I guess anything that implements responder will immediately call respond2 after it is returned, or something like that, to where you get respond2 returns a boxed future of an HTTP response and an error. That would make sense, I think. Response with custom type. To return a custom type directly from a handler function, the type needs to implement the responder trait. Let's create a response for a custom type that serializes to application JSON response. So we have Actix-Web, and we're importing box body, HTTP header content type, and insert a serialize. Derive struct serialize. So we're serializing this struct, my object. Okay, and then we're implementing responder for that struct. Right, and then, like I said, here's the response to function, which is like the criteria for it to be the responder. And we're setting the type of body to box body. So this response takes self, which is my object that we're implementing on, and a request. So it takes a reference to an HTTP request and returns HTTP response self body, which is a box body for this object. That is struct. So we let the body equal JSON to string self unwrap, which we can do because it was serialized. Create response and set content type. Okay, so here we're setting the content type to JSON because it was serialized, which makes sense. And then the body of the HTTP response is this variable we made. Gotcha. And then we make a function that returns an implementation of responder. Okay, yeah, so now that we've done all of this my object does in fact implement responder, so we can return it instantiated with the name user. I think that was all right. Probably not. So, streaming response body. Response body can be generated asynchronously. In this case, body must implement the stream trait. Stream item is bytes and error is error. Okay. So futures, future okay, stream once. So on the stream path, we're going to return an HTTP response once. So this is part of futures, right? Yeah, so futures stream once using the once method. Okay, anonymous error, web, bytes from static. Okay, so we're making this a static byte stream. So this is in bytes. We're making it static. So web bytes from static. Gotcha. HTTP response, content type, application JSON, streaming body. So I guess it doesn't need to be serialized. Interesting. But we call streaming here instead of like server or service. This is a response that we're building. That makes sense. Gotcha. New app, new service stream. Okay, so this tiny little app that we've got is just going to serve up this stream function that returns this byte, the static byte stream of test. Makes sense. Different return types, either. Okay. Sometimes you need to return different types of responses. For example, you can error check and return errors, return async responses, or any result that requires two types. Oh, that's neat. For this case, the error type can be used. Either allows combining two different responder types into a single type. Actix-Web, either error HTTP response. Type register result equals either HTTP response or result reference tick static stir error. So this is interesting. So you have, are we going to match on this? I guess it wouldn't be a match, it would be an if else. Yeah. So there's an if else over this. Yeah. So for, you have a left side and a right side. That's cool. And either is just a thing that lets you put two types in, and then you can match inside your function. So we made this register result type. So it returns a register result type. If is a variant, choose the left variant. So the left, HTTP response, bad request, body, bad data. Right? And then right is okay, hello. That's pretty cool. I like that. All right, extractors, the last portion. Looks like a big one though, so that's great. Extractors. Type safe information extraction. Actix-Web provides a facility for type safe request information access called Extractors. Implements from request. By default, Actix-Web provides several extractor implementations. An extractor can be accessed as an argument to a handler function. Actix-Web supports up to 12 extractors per handler function. Argument position does not matter. Huh. So what do we have here? Async function index. Path is a web path. String, JSON, implements responder. Path is into inner. Format. Path 0, path 1, JSON ID, JSON username. Type safe request information. So you can like get really granular about how your roots are used, I guess, which is good. Path provides information that can be extracted from the request path. Oh, so you can go into the path and use things. You can deserialize any variable segment from the path. For instance, for resource that registered for the user's user ID / friend path, two segments could be deserialized. User ID, this, and friend, this, because it's in the curls. Interesting. These segments can be extracted into a tuple, path u32 string, right, to reflect the paths, or any structure that implements the deserialized trait from the Serde crate. Cool. Serde is everywhere. It's great. Okay, so let's look at this. Use Actix-Web, get web results. So extract path info from user's user ID friend. This deserializes into a 32. This deserializes into a string. So in the case that this is the path we get fed, we're going to, the function will take the path here, and it should be a path of u32 string, and it returns a result of string, and then we can do stuff with those variables. Path into inner. Cool. And then you just do regular stuff. I don't know why are we importing down here? It seems weird to me. Why not put app in HTTP server? If you know the answer to that question, please let me know, because that's weird to me. It is also possible to extract path information to a specific type that implements the deserialized trait from Serde. Here, it is an equivalent example that uses Serde instead of a tuple. Oh, okay. So it's saying you can also deserialize structs so that they can be used as types and then fed information, fed data from the path. That's cool. And then regular stuff for the server. Would it fail to compile if we tried to extract more path variables than are declared in the URLs handler? Let's find out. Let's use this one because it's simpler. Why is this not working? Okay, there we go. Does this work? Hopefully we have everything imported. So it's going to be user ID friend, so it needs a number and a string. Hope it runs. And it was users, right? Yeah, okay. It's running. So we need to do users. Cool. Okay, so that worked. And we're going to see if it fails if we do like something like this. So I don't know if that's failing, but it's not calling the function, I guess. So it's just saying that this doesn't work. This is not the path you were searching for. But yeah, it's not going to fail to compile because the compiling is just running the HTTP server. Whether or not you give it a correct path is up to you. I think that makes sense. That's a good question though. And it's just saying that you can do the same thing with structs that are deserialized. So it is also possible to get or query the requests for path parameters by name. So you're saying if you declare path U32, string U32, but only declare two variables in the URL above. Yeah, I think that would be the same thing. So we could do that by just not providing this, right? And that would be a similar example. And then if we tried, yeah, I think it just doesn't hit the path. Like it needs to fit this number string format in order to call the function at all. Hopefully that answers what you were saying. So it's saying that you can decorate it the same way here. What is it saying? And then you can get or query the request for path parameters by name. So whatever you call here, you can say get or query directly in your code. Parse unwrap, interesting. And then it will return it here. So I guess instead of using the deserialized stuff, you can do this. And then regular HTTP server stuff. Okay, query. The query type provides extraction functionality for the request query parameters. Underneath, it uses Serde URL encoded crate, which I've never heard of. So regular stuff, and then Serde deserialize. We're deserializing a struct. This handler gets called if the request deserializes into info successfully. Otherwise, it gets a 400 bad request. It's returned. So if we query info, so this is how we would get the bad request, I guess. I don't know. Huh. So this is how you would check to make sure that you're giving it a legitimate path. Let's see, how are they doing that? Function query info. You have to do it like with a struct, I guess. Interesting. JSON. JSON allows deserialization of a request body into a struct. To extract typed information from a request body, the type T must implement the deserialized trait from Serde. Must implement the deserialized trait from Serde. So you have to give it this in order to make it JSON, which is sort of what Serde does. So that makes sense. So in order to do this part, okay, format, welcome, and then you can access it. So this reads it in as JSON, which is nice. Some extractors provide a way to configure the extraction process. To configure an extractor, pass its configuration object to the resource's data method. In the case of JSON extractor, it returns a JSON config. You can configure the maximum size of the JSON payload as well as a custom error handler function. The following example limits the size of the payload to 4 kilobytes and uses a custom error handler. Oh. So we're dealing with configs now. This is 4 kilobytes. And our function uses JSON, which is deserialized. And then, okay, so inside the server, we're declaring this variable of the JSON config to limit it to 4 kilobytes after web JSON config default. And then we're providing some error handling with a custom error response. From response, HTTP response, conflict, finish. Interesting. And then we're running the app. Still inside the closure. This whole thing is inside the closure. And this is, so, okay, so we passed the JSON config we made as app data. Change the JSON extractor configuration. So I guess it has, so under web resource here, I guess it has a default configuration. And then we're changing that. And then we're giving it the root host to index. Oh. Right. Forms. Form. At the moment, only URL encoded forms are supported. Okay. The URL encoded body could be extracted to a specific type. This type must implement the deserialized trait from the Serde crate. Form config allows configuring the extraction process. Let's see. Use Actix-Web, results, deserialize, derive deserialize form data. So extract form data using Serde. This handler gets called only if the content is XWW form URL encoded. So I guess that's just how you tell if it's a form. content of the request should be, or could be deserialized to a form data struct. Okay. So it's web form. Okay, so web has a form type that takes T, which is form data here, but it has to be deserialized. Okay, interesting. Just trying to cover the basics. Learning how to crawl is what we're doing here. Actix-Web also provides several other extractors. Data, if you need access to an application state. Okay, so like internally. HTTP response, or HTTP request itself is an extractor, which returns self in case you need access to the request, again, internally. String, you can convert a request payload to a string. Example is available in docstrings. Actix-Web, web bytes. You can convert a request payload into bytes, example in the docstrings. Payload, you can access a request payload. Example. Look at this. Raw payload stream. So, what are we doing here? Futures util body payload. So post at root web payload extracts raw payload stream from request. Index mute body web payload returns Actix-Web results. For a demonstration only, in normal case, use the bytes extractor. Collect payload stream into a bytes object. Bytes mute. Let some item equal body dot next, which was a parameter dot await bytes dot extend from slice. I only vaguely understand what that's doing, so we're just gonna go back to this. Application state extractor. Application state is accessible from the handler with the web data extractor. However, state is accessible as a read-only reference. If you need mutable access to state, it must be implemented. Beware, Actix creates multiple copies of the application state and the handlers. It creates one copy for each thread. Wow, okay. So that could have some accidental bloat, I guess. Here's an example of a handler that stores the number of processed requests. So we have a responder in standard cell. So we're deriving clone for some reason onto our app state with a count of cell usize. So we're going to make a function called showCount and a function called add1. And they both return a responder. This one is going to get the count, makes sense. This one is going to get the count and then set it to one more than what it is. And then print it. Actix-Web main. Standard IO result. Use Actix-Web app HTTP server. Again, we're importing inside of main for some reason that I don't understand. And then we instantiate inside main, which makes sense, outside of the server. And then we move it. And then we clone it, which is, I guess, why we have clone on our struct. Since we have to do that after the move for the threads. And then at the base, we show the count, and afterwards, we add one. So this is not going to work, right? Although this handler will work, data.count will only count the number of requests handled by each thread. Right. To count the number of total requests across all threads, one should use arc and atomics. So Actix-Web, all of this stuff, and then we're adding atomic usize. So standard sync atomic usize ordering, and then standard sync arc. Oh, we're gonna have to sprinkle orderings everywhere, aren't we? Vaguely remember what those are. Local count, global count. to show both. And then get show count using new lines. So here we have to global count, add relaxed ordering. So that's just like the least strict possible. And we're adding one for each. So we fetch. So there's like a specific function for doing this asynchronously. And then you have to feed it an ordering as well. Local count, you do the regular way of incrementing. And then you load both to print it. And then this is all going to be about the same. You instantiate with whatever the count is. Arc new atomic usize new, which matches with our arc atomic usize. And then HTTP server new move to the app. And then the app data is going to be from web data new data.clone. So we have to clone it again. And then we're going to run these functions of showing and adding. So the show is going to print both though. Let's actually see what this looks like. It looks like this is all right here. This, and this should work if we did everything right. And then this will kill and run it again. This stuff. Okay, cool. So that worked. Show count. Did I get that right? Oh no, it's going to be base and then add, and then yeah. So whenever we go to the base, that's how it's stacked up. It's going to show the count. So let's do it that way. I tried to type the function in for some reason. Okay, it starts at 0, and then we should be able to add. Nice, it goes to 1, and then so the global goes to 2, the local stays at 1, global goes to 3, local stays at 1. But these are, so 1 is staying on 1 thread. Ooh, it hit a 2. Does that mean that I only have 12 cores, 12 logical CPUs? I don't actually know. So that means that if I got to 24, 25, it should go to 3. That is my hypothesis. Nice. Cool. It works how I thought it would work. That's neat. That's really neat. Concurrency is awesome. Atomics. Who would have thought? Note, if you want the entire state to be shared across all threads, use web data and app data as described in shared mutable state. Whoa. Okay. Be careful with synchronization primitives like mutex or rwlock. The Actix-Web framework handles requests asynchronously. By blocking thread execution, all concurrent request handling processes would block. If you need to share or update some state from multiple threads, consider using the Tokyo synchronization primitive. So it's saying like going across threads. That was cool. I think that was the last one. Man, okay, that was a lot. That was a lot of information. It was fun though. It's becoming less and less complicated the more that I learn, which means that it's good API. That's great. If you are watching this and you now know of some tutorial or blog post or something that is written in Actix-Web 4, please let me know. Put it in the comments. I want to check it out. I could not find anything. But yeah, I hope you enjoyed this. Hope it was fun. Let me check the chat one more time. All right. I will see you next time.